Let's discuss Newton's three laws of motion and how they apply to simple machines. Here we have a series of pendulums. At any given time, only the one at the end moves. So what you have is an object that is moving and an object that is at rest. So the first law states that any object, whether it's at rest or in motion, will stay that way until an outside force acts upon it. So the second pendulum here will stay resting until this one here, the one that's moving, goes out and hits it. The second law of motion states that the ability of an outside force to create a change in motion depends on the object's mass. So a larger mass will require a larger force to move it, and a smaller mass will require a smaller force to move it. So here we have a weight or a mass of, let's say, 5 tons, and it requires a certain force to be able to move it or accelerate it upwards. Here we have a smaller mass, and the force that's required is a smaller force. Now, Newton's third law states that every action or every force, when it acts upon an object, it has an equal and opposite reaction. So, going back to our example, we have a force here, and the reaction of that force is that in fact we are able to move the object upwards. And here you have our three laws of motion. Now let's see how they apply to an example that we can use with a simple machine. So the simple machine that I have chosen is an inclined plane. So here we have an inclined plane with an angle that's not very steep, and we have another inclined plane, and for this one the angle is a little bit more steep. In both these cases, if I was to put a ball bearing on any of them, the ball bearing would roll down, and that is because there is a force of gravity that is acting upon each plane, and the force of gravity in both cases remains the same, so gravity doesn't change. Now, what is changing, however, is the reaction. So in the first plane, what we have is a reaction that's almost equal to the force of gravity. And so in the second one, what you have is a very small reaction to gravity, because of course it doesn't provide a lot of resistance. In the first case, what happens is that the leftover goes towards the motion of the ball, and the same thing happens on this side. So both the green arrows are equal to gravity. In one case, most of the leftover goes into motion, whereas in the first one, most of the leftover goes into just a simple reaction of keeping the ball up.